So, Pluto's this planet way out there that used to be part of our solar system. But then some scientists, like Neil deGrasse Tyson and Mitaku, said some stuff that got everyone talking about it again. They think Pluto might crash into Neptune. How could that even happen? And what if it did? Is this just some crazy idea, or is there something to it? Let's look at what could happen if Pluto and Neptune actually collided. Pluto, which got demoted to a dwarf planet, is a good example in the huge universe, and experts can't stop talking about it. Pluto's path is super close to Neptune's. Neil deGrasse Tyson and Kaku are warning that these two planets could crash. It sounds bad for Earth. But how could this even happen? Pluto goes around the Sun differently than any other planet. It takes 248 years to go around just once. Since we found it in 1930, it hasn't even finished one lap. And get this, Pluto's path isn't a circle like the other planets. It's more of an oval. Plus, it's tilted at a weird angle of 17 degrees compared to the other planets. It is so unpredictable. Here's a crazy thing, for about 20 years of its orbit, Pluto is actually closer to the Sun than Neptune. So why haven't they crashed? It's because of how the other planets pull on them. They started figuring out Pluto's orbit soon after they found it. It was weird compared to the others. Even though Pluto's orbit is all over the place, it's actually pretty stable. This proves how complicated space stuff can be. The three-body problem is about how three things in space such as Pluto, Neptune, and the Sun affect each other. For Pluto, this problem shows how its orbit, Neptune's orbit, and the Sun's gravity all work together. Scientists mention things like non-simultaneous vibration, orbital precession, and VZK wobbling. These are key to understanding this. Non-simultaneous vibration means that when Pluto crosses Neptune's path, it's always super far away from Neptune. This helps keep them apart. Orbital precession means Pluto moves up and down in its orbit. So, when it's closest to Neptune, it's far above it, which stops them from hitting each other. Then there's the VZK wobbling thing. It's named after some scientists. It is about how three space objects pull on each other. For Pluto, this wobbling helps keep its path smooth, even though it looks weird near the Sun. So, even though space seems crazy, things follow patterns. These things keep Pluto from crashing into Neptune or flying off. This three-body problem helps us figure out how orbits change. By checking this, we can learn about Pluto, our solar system, and even galaxies far away. Computer guesses in the late 1980s showed that even if Pluto's orbit stays okay, it's still weird. Even something small at the beginning can end up making a big difference later on. But over a long time, Pluto's orbit stays basically the same. Checking these changes helped us figure out how the big planets like Neptune, Jupiter, and Saturn affect Pluto's path around the Sun. Neptune and Pluto have a special connection. For every 2 times Pluto goes around the Sun, Neptune goes around 3 times. This helps keep Pluto steady. But it's not just Neptune. Jupiter's gravity helps, too. And even Saturn plays a part. It looks like Neptune, Jupiter, and Saturn work together to make sure Pluto doesn't crash into anything. If not for these unique qualities, the solar system would be messed up. Bodies like Pluto could crash into each other or get launched out of orbit, which would cause problems. It gives a more clear understanding of the solar system. This happens on Pluto, especially since it has a chance to crash into Neptune later on. Pluto shows us that even wild-seeming orbits can stay balanced because of gravity and how orbits work. Watching and checking things is so important. Going deep into space shows us that some things are just strange. For example, Pluto's orbit. It has something called orbital chaos. This means that just a small change in Pluto's position or speed can totally change its orbit over time. Scientists use computers to see where Pluto is in space thanks to these computers. These simulations use math to copy how Pluto and Neptune affect each other by affecting small details. It can make a big difference in where Pluto is. Back in the 1980s, these simulations showed something interesting. Even though Pluto has vibration and precession, its orbit can still be odd. Something tiny on Pluto could make its orbit look totally different after a few years. But even with all this chaos, Pluto's orbit stays steady for billions of years. It makes it wild at first. Trying to guess where things will go in space, like Pluto, is super hard. These systems are unpredictable, so getting long-term predictions can be very tough. Math models are helpful for figuring out this, but don't always tell the whole story. Since the models are only as accurate as the numbers you put into them, so a small mistake can lead to really wrong results. Pluto reminds us that our world can change. Pluto reminds us that our knowledge of the universe is still missing something. Seeing how the big planets affect Pluto's orbit helps us understand the solar system better. It shows us how each planet can change other planets. So, why are some scientists warning us about Pluto and Neptune crashing into each other? Neil deGrasse Tyson, who is well known in the cosmology field, shares interesting views, especially Pluto. Tyson is known for renaming Pluto from a planet to a dwarf planet is still insightful, and the public is still interested in it. Tyson thinks renaming Pluto isn't about lessening it. He views the complexities of orbits like Pluto's as a sign of how much there is still to discover in space. He is curious about it. Tyson's hopeful. He still has thoughts about Pluto and potential crashes between Neptune based on unstable orbits. Tyson knows that even if Pluto's orbit has been okay, it can still turn south. There is a chance that Pluto's path, especially when it gets close to Neptune, and also small shakes in Pluto's orbit could have big effects over millions of years. So, ongoing observation and an understanding of Pluto's orbital dynamics needs to continue. Makaku shares Tyson's thoughts about space with enthusiasm. Makaku is aware of planetary orbits and the unstable effects that could come in time too. Over time, it will only lead to continued research. The story of Pluto shows that our understanding of the universe is always growing. And we should keep our minds open.